everybody, I'm Professor King, and today we are doing EDTA titration of drinking water in order to determine calcium ions. Calcium ions are indicative of total hardness due to dissolved minerals, primarily calcium carbonate minerals. And so what we have for setup here is a burette containing the titrant, which is EDTA. The initial volume has already been set to 0 mils. So it's perfectly lined with the 0 mil mark. And the sample is 25 mils of, this one is Brita. It's Brita filtered well water. And we need to adjust the pH of the sample to pH 10. So I will add, before I start this, I will add 1.5 mils of buffer. And also, because the reaction is, nothing is colored, in order for you to determine whether you have reached the endpoint, that means the reaction between EDTA and calcium ion is complete. Without any color change, we can tell if the reaction is complete. And so the indicator for this type of titration, EDTA titration, is called areochrome black tea. And we have made a more concentrated solution than we were hoping. So instead of 3 drops, as the procedure calls for, I am just going to add 2 drops. And then make sure you swirl your solution, mix it well. And the initial color, before you add EDTA, is wine red. We are expecting an endpoint color, which is blue, when the reaction between calcium and EDTA is complete. So I'm going to begin titration, and as I mentioned earlier, the initial volume, initial burette reading rather, is exactly 0 mils. Now you don't have to start with 0 mils, but I'd like to start my first titration at 0 mils. In that way, as I proceed with the titration, I don't have to do much math. The final volume reading will be the volume that I use for titration in order to reach the endpoint. Alright, so to start titration, just make sure you're comfortable with the burette and you can control the stopcock. There are 2 ways to do titration. Some students will control the stopcock from this T shape here. I am more used to doing it this way, where I wrap my finger around the stopcock and slowly turn it. While you're doing titration, you want to swirl the solution constantly so you have a homogeneous mixture. And as you notice, I'm doing the titration at a rapid rate in the beginning. What you need to watch out for is the purple color, which is a mixture of the pink and blue endpoint, and that indicates that you are nearing the endpoint of the titration and you have to slow it down. Continue titrating, drop by drop. Okay, I see some bluish tint now. So what I have here is a reference color of something that I titrated earlier. So this is the blue endpoint color. And I think I'm still a little bit further from the blue color. So what I'm gonna do is keep doing the same thing. Add 1 drop of EDTA. Okay, that's a little bit more than 1. Luckily, it's still a little bit purple, but I do have a fraction of a drop suspended on the tip of that burette, so I'm gonna touch that against the wall of the Erlenmeyer flask, and I think it does the trick there. So what I'll do is rinse that down. That drop that might be adhering on the side, and I have done this titration. I can tell that this is now blue and not purple. So this is the endpoint color. This is how the endpoint looks like when the reaction is complete. All right, so we finished 1 titration. There's one more thing that you have to do. Because I'm vertically challenged, I have to bring down the burette to my eye level. So I have to again unclamp it in order to read the final volume. And the trick is using a white background with black line. So hold it against, remember you have to read from the lower meniscus. And right now the volume is 17 point, trying to read between the lines here, which I think is where it is. So 0.5, 0.6, 0.7, 0.8, but not 0.9. So I would say it's between 17.8 and 17.9. And you have to estimate the final digits. So I would say 17.88. Okay. So final reading is 17.88. Again, the second decimal place is estimated because it's too close to 17.9. I estimated the reading to be 17.88 mils. And see, that's why I like to start at the 00 mark, because it's easy to do the math. So now by subtracting the initial reading from the final reading, the volume that I used in order to reach the end point is 17.88 mils for Breda filtered water. So that's it. That's 1 trial. And let the titration begin. All right. So add the titrant slowly while swirling your sample. Since the endpoint color is blue, when you see a purple intermediate color, you might want to slow down, which is what I'm doing right now, although I don't see the purple yet. And there is the blue color that we were expecting at the endpoint. So I will stop the titration now. That's why it's called end point. You end the titration. And I'm going to record the final volume of EDTA. And right now, use my black line here. It looks like it is exactly 8.00 mil. .00 mils, blue endpoint. Okay. Let's start titration. So what I'm missing is 3 drops of indicator. I already added the buffer. 1, 2, 3. Let's make sure the indicator is dissolved completely. And then lower the burette tip so it's inside the Erlenmeyer flask. We already recorded the initial volume reading at 8 mils. So let's start our second titration. And just lower it a little bit more. So again, this is treated well water. Now, treated well water means it, because well water is acidic, it passed through calcium carbonate or limestone treatment in order to neutralize the acidity, which is corrosive to pipes and other metals, but it adds calcium to the sample. So I expect this one to have a higher calcium content than the untreated well water. And again, the key here is once you see the purple intermediate color, that's when you slow down the titration, which is this color here. Alright, so from this point on, I'm going to add the titrant. Wait a second. It's hard to tell, it's so dark. I think this is already our blue endpoint. So what I'm gonna do is, because I'm not 100% certain if it's blue, it's just so dark, I'm going to record the current reading, burette reading, and it is, now this one is at eye level, so I don't have to unclamp the burette, and it looks like, so I'm lining up the bottom meniscus, 31.5, 31.6, and it looks like it's perfectly lined up with the 6th mark. So I will call this as 31.60 mils. 31. Dropper. You could always edit or not use this one.
Oh, you can even see it better in that.
Okay. Yeah, that was the blue color. It is blue. Okay. So I didn't really see it change before from when I record the final volume, and when I pipette a little bit of that solution, it does look blue to me, so I will stop the titration here. But what I will do is use that final reading that I already noted earlier as my endpoint. Slowly open the stopcock. Oops, blooper. Good thing it's not blue. All right. having some problem putting on my gloves. And that's why they invented the powder gun, but we don't want that the powder contaminating our samples. So I'll settle with that. It just wouldn't go all the way in. Okay. Let's start titration. So